Well, if you've ever walked around UBC, chances are you've walked right over it without even knowing. A 2.5-kilometer underground tunnel that plays a critical role in the research of Parkinson's disease. As Linda Aylesworth reports, it's a system that literally rockets radioactive isotopes to the laboratories that need them.
Since the early 80s, the Pacific Parkinson's Research Center at UBC Hospital has been a world leader in its field, namely unraveling the mysteries of Parkinson's disease. Their work wouldn't be possible without this tool, a PET scanner.
It's really the backbone of our research program. If we want to understand chemical changes in the brain in living humans, there's no question the best way to do that is with PET scanning, or positron emission tomography. Also that the normal is actually lower than the Parkinson patient in that region.
But these images created by the PET scan wouldn't be possible without one essential ingredient: isotopes, radioactive molecules that light up parts of the brain. Molecules that are made just down the road at Triumph, one of the world's leading subatomic physics laboratories.
The compounds that we make here decay very quickly, and so they have to be made and used immediately.
Carbon-11, one of the isotopes used for Parkinson's research, has a half-life of just 20 minutes. What does that mean?
By the time 20 minutes have elapsed, you're down to half of what you started off with. And in another 20 minutes, you'll be down to a half of that, so a quarter of what you started off with. But the decay is a continuous process.
So you've got to work fast.
We do indeed.
So just over 25 years ago, when the partnership between Triumph and UBC began, they dug a tunnel between their buildings and installed a 2.5-kilometer-long pneumatic tube, affectionately known as the Rabbit Line.
It runs underneath the side of Westbrook Mall, and it's a couple of meters below ground, and it's encased in concrete. And it takes just over 2 minutes. So it has a peak speed of about 120 kilometers per hour, but the average speed is 60 kilometers an hour.
This is how it works. As soon as the isotopes are ready on Triumph's end, they're transferred into a capsule, inserted into the opening of the Rabbit Line, and with a powerful burst of compressed air, they're sent on their way. 2 minutes later, over at the Parkinson's Research Center, which goes to show that even in a high-tech world, you sometimes can't improve on low technology.
We take it for granted, but it's an incredibly robust piece of equipment that has operated almost flawlessly for 30 years. So it's certainly a tribute to the engineers and the Triumph staff that designed and built it.
Oh, that's a neat little story. 8:22. Nice work there, Linda. Very interesting.